When you wake up in the morning, do you have an insatiable urge after you brush your teeth, put on your clothes, eat your breakfast, get in your vehicle, and drive to God knows wherever you need to go to get your arrows popping? Good. You're in the right place. Check out this new video by Fort Bend Tutoring and Mr. Witt.
Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today we have a tutorial on verifying trigonometric functions part 4. That's right. This is the final video in this series. Thanks for coming back. Appreciate it. So we're going to have an additional 8 problems where we, you and I, try to prove the left side equal to the right side, or you can make the right side equal to the left side, or you can work both sides down to a point to where they both equal one another. However, my preference, is to always make the left side equal to the right side. That's just what I like to do. Okay? So in this problem, we have tan squared theta divided by 1 plus tan squared theta equals sine squared theta. My first step is to recognize, using my Pythagorean identity, that 1 plus tan squared theta is equivalent to secant squared theta. It is. So we have tan squared theta over secant squared theta. Okay, so this is what I have thus far. This can be rewritten as a division problem. All right, so I'm going to show that I have tan squared theta divided by secant squared theta, knowing that every fraction is a division problem, right? From here, I'm going to rewrite these tan and secant functions and break everything down into sine and cosine functions, all right? So I know, using my quotient identity, that tan squared theta is equivalent to sine squared theta all over cosine squared theta, all right? And this is going to be divided by, using my reciprocal identity, secant squared theta can be rewritten as 1 over cosine squared theta, just like that, right? So now that I have two fractions dividing, I know that in order to divide two fractions, I need to end up multiplying by the reciprocal, the flip, of the second fraction, right? So let's write that. Let's go ahead and show that. So I'll have this rewritten as sine squared theta over cosine squared theta times cosine squared theta over 1. All right? From here, ladies and gentlemen, you should realize that we can simplify before we multiply. In other words, as long as we have one factor in the numerator over a common factor in the denominator, that equals to 1. So therefore, we can cancel it out. And what cancels out is our cosine squared thetas. Goodbye. They're gone now. So this is now equal to sine squared theta over 1, which simply reduces to sine squared theta. And now our left side equals to the right side. And that's it. That's problem number 1. We are now moving on to problem number 2. All right, you and I, together, you and I. Problem number 2, I have cosine x divided by 1 plus sine x plus 1 plus sine x divided by cosine x. And this is supposed to equal 2 cosecant of 90 degrees minus x. All right, this reference here, that 90 degrees minus x, you should recognize as a co-function identity. That's right. So anytime you see some screwy in some parentheses like that, it's an identity. Yeah, just look for it. You need to make sure you recognize that. And behold, I will be providing that information, those notes, at the bottom of the screen there. Okay? So keep that in mind. I have your back. Mr. Witt has your back. Always. So let's begin. What we'll do first here is we'll get a common denominator, which is going to be the product of 1 plus sine x times cosine x. So I'm going to go ahead and set up my framework here. I'm going to set up my framework. Thank you very much. There you go. I know that my common denominator between these two fractions here is going to be cosine x times 1 plus sine x. Thank you. All right, and I'll need that over here as well. Here it is. It's coming. It's coming. Be patient. There we have it. All right, let me get that in view. Thank you. And whatever I had to multiply the original denominator by, in order to get an equivalent fraction, I need to multiply the numerator by that same thing. So notice that from our 1 plus sine x to our common denominator, we had to multiply this original denominator by cosine x. So multiplying cosine x times cosine x, that gives you cosine squared x. All right, and that's our new numerator. numerator there. Thank you. Now, comparing our original denominator of cosine x into our common denominator, our LCD, we had to multiply by 1 plus sine x. Yeah, we did. So I'm going to go ahead and show that this is going to be 1 plus sine x squared. All right, so this is what I have thus far. Now that I have this, I can combine my numerators together. And when I do that, I'll also be expanding that binomial that's squared there. Okay, so let me show you what I'm talking about. My new numerator, when I combine these two fractions, will be cosine squared x plus 1 plus sine x times 1 plus sine x. All right, all over my common denominator, which is cosine x times 1 plus sine x. All right, so this is what I have thus far, just like that. From here, ladies and gentlemen, what I'll do is I'll be multiplying this out here, and I'm going to go ahead and show my work. All right, I'm going to get my arrows popping over here. Okay, so everything will be multiplying in the numerator. That binomial times a binomial. I will be bringing down that cosine squared x. All right, haven't forgot about that. Plus 1 times 1 is 1. 1 times sine x is sine x. Then sine x times 1 is another sine x. Thank you. And then sine x times sine x, that gives me a positive sine squared x. All of this is over cosine x times 1 plus sine x. Okay, so this is what I have thus far, ladies and gentlemen. From here, I'm going to show that this cosine squared x and that sine squared x, that's a Pythagorean identity. Yeah, cosine squared x plus sine squared x, that equals to 1. So I can now rewrite this as 1 plus 1 plus, let's go ahead and combine that sine x plus sine x to give me 2 sine x. All right, which is all over cosine x times 1 plus sine x. All right. So that's what we have thus far. Last time I checked, ladies and gentlemen, 1 plus 1 is still 2. So combining those like terms in the numerator, you now have 2 plus 2 sine x all over your common denominator, which is cosine x times 1 plus sine x. Just like that. Next thing that I'll do is I'll be factoring out a 2 in the numerator here. All right, so factoring out 2, I have 2 times 1 plus sine x, all of which is over this cosine x times 1 plus sine x. All right. Now you should see that we have the identical factor over itself. Let's go ahead and cancel this out. All right. So my 1 plus sine x's will cancel out. That simplifies this to 2 divided by cosine x. And if I were to expand this, I could show that this is going to be 2 times 1 over cosine x. Using your reciprocal identities, we know that 1 over cosine x is secant x. All right. And using our cofunction identity, secant x is equivalent to cosecant x, bring over that 2, 90 degrees minus x. Just like that. Left side now equals to the right side, ladies and gentlemen. There it is. That's a check mark. It's an ugly one. I'm going to fix it. That's an ugly check mark too. That's an ugly check mark too. That check mark is going to have to do. Left side equals to the right side. That's problem number 2. Moving on to our next problem. All right, problem number 3. With problem 3, we have secant squared x plus cosecant squared x equals secant squared x times cosecant squared x. Right, so I'm going to begin by rewriting the left side using only sine and cosine functions. So using my reciprocal identity here, I can rewrite that secant squared x as 1 divided by cosine squared x. Yep. The cosecant squared x can be rewritten as 1 divided by sine squared x. All right, like that. Okay. Now, getting a common denominator, I'm going to go ahead and set up my framework here. Thank you. There you go. My common denominator would have to be cosine squared x times sine squared x. So let's go ahead and set that up. Thank you. There you go. You guys are being real nice today. I appreciate that. Okay. You're being very supportive. I appreciate the participation. That's real good. You're writing down your notes, which is excellent. Good stuff. You're making references to your properties that we're using. And we need to get equivalent fractions here, right? Yeah. So I had to multiply the original denominator by sine squared theta, and sine squared theta times 1, yeah, that's just sine squared theta, okay? That is not an R, it's an N. Then, ladies and gentlemen, we had to multiply the sine squared x times cosine squared x to get our common denominator. So cosine squared x times 1 is cosine squared x, just like that. Yep. Now that we have equivalent fractions with a common denominator, we can combine those numerators together. So this gives us sine squared x plus cosine squared x, all divided by cosine squared x times sine squared x. Well, your numerator, ladies and gentlemen, is a Pythagorean identity. Yeah, sine squared x plus cosine squared x is always equal to 1. All right, and that's going to be over your cosine squared x times sine squared x. Yep. Okay. Expanding this 1 over cosine squared x times sine squared x can be written as 1 divided by cosine squared x times 1 divided by sine squared x. And using your reciprocal identities, 1 divided by cosine squared x is secant squared x, and 1 divided by sine squared x is cosecant squared x. Left side not equals to the right side, ladies and gentlemen. Done. I hate these check marks. Okay, there's something going on today with these check marks, and I don't know. There you go. That's going to have to do. Okay, I hate it too. All right, let's fix that. We're going to get it. We're going to get it. Better. I like that check mark. There you go. That was problem number 3. Number 4 is next. All right. Let's check this out together. Hand in hand. Hand in hand. Here we go. Problem number 4, we have the quantity of cotangent theta plus tan theta squared equals cosecant squared theta times secant squared theta. We're going to begin by expanding the left side. That's right. I'm going to write out this binomial squared twice. So that means I have the cotangent theta plus tan theta times cotangent theta plus tan theta. Okay, now that I have a binomial times a binomial, I will be getting my arrows popping, ladies and gentlemen. So let's go ahead and show that. I'd like to get my arrows popping for all of you. And multiplying this out, cotangent theta times cotangent theta is cotangent squared theta. Yes. Then cotangent theta times tan theta, yeah, multiplying those reciprocals, you end up with 1. Okay, tan theta times cotangent theta, another 1. Thank you. And tan theta times tan theta gives you a positive tan squared theta. That's what we have thus far, ladies and gentlemen. Yeah. Go ahead and from here recognize that our cotangent squared theta plus 1 is a Pythagorean identity. This right here, that's an identity. And so is this, by the way. Okay, the cotangent squared theta plus 1 is equivalent to cosecant squared theta. And the 1 plus tan squared theta is equivalent to secant squared theta. All right. Isn't that cute how that worked out? Okay, so from here, this is what's going to happen. We're going to now rewrite this cosecant squared theta and the sine squared theta using only cosine and sine functions. So this becomes 1 over sine squared theta plus 1 over cosine squared theta. All right. Then getting a common denominator, let me set up my framework. Thank you. I'll have sine squared theta times cosine squared theta for my common denominator here. All right. Can I squeeze this in here? We had to multiply sine squared theta times cosine squared theta to get our common denominator. That means that cosine squared theta times 1 is cosine squared theta. What I'm doing is getting equivalent fractions here. I had to multiply cosine squared theta times sine squared theta to get that common denominator. So sine squared theta times 1 is sine squared theta. Okay. From here, you would combine your numerator together, right? Okay, so you should know by now that your Pythagorean identity, that cosine squared theta plus sine squared theta is equivalent to 1. So you would have 1 over that common denominator of sine squared theta times cosine squared theta. All right, we can expand this to show that this is 1 over sine squared theta times 1 over cosine squared theta. Well, it turns out using your reciprocal identities, you should know that 1 over sine squared theta is cosecant squared theta. And then 1 divided by cosine squared theta is secant squared theta. All right. And that checks out. Left side equals to the right side. On to problem number 5. All right, in problem number 5, we have sine x divided by cosecant x plus cosine x divided by secant x, and this equals to sine x cosecant x. So what we're going to do is we're going to write everything in terms of sine and cosine. So that means that I have sine x all over 1 over sine x. All right, if it comes out, there we go, plus cosine x divided by 1 over cosine x. All right. From here, I'm going to go ahead and multiply the numerator and the denominator of that first fraction there times sine x. So it looks like this. I have sine x over 1 over sine x times sine x over sine x. Okay? Plus cosine x over 1 over cosine x. And I'll be multiplying by 1 in the form of cosine x over cosine x. All right, so this is what we have thus far. Now, multiplying straight across, our sine x times sine x gives us sine squared x. All right, and then 1 over sine x times sine x is just 1. All right, then cosine x times cosine x is cosine squared x, and then in the denominator, that 1 over cosine x times cosine x is just 1. All right, so from here we just have sine squared x plus cosine squared x. And last time I checked, using your Pythagorean identity, sine squared x plus cosine x equals to 1. Left side equals to the right side. We're done. That was problem number 5. Now we're on problem number 6. We have the quantity of cosine x minus sine x squared plus the quantity of cosine x plus sine x squared, and this is supposed to equal to 2. We're going to start by expanding everything. That's right. So I'm going to write these binomial squareds right next to one another and then multiply them all out. Oh yes, sounds like fun, right? So we have the quantity cosine x minus sine x times cosine x minus sine x plus cosine x plus sine x times cosine x plus sine x. Oh, I am squeezing that in there, aren't I? That is a hot mess over there, but it's simply just the cosine x plus sine x written again. Just trust me. All right, we're going to get our arrows popping, okay? So we're going to be multiplying these binomials out, all right? I know you want to see it. There you go. There's your arrows. All right, greedy people. So cosine x times cosine x is cosine squared x. Cosine x times negative sine x is going to give us a negative cosine x times sine x. Then negative sine x times cosine x is another negative cosine x sine x. And then finally we have negative sine x times negative sine x to give us a positive sine squared x. But we're not done. No, we're not done, because we have these other binomials here that need to be multiplied out as well. So we continue with cosine x times cosine x, which is going to give me cosine squared x. Then cosine x times sine x is going to be positive cosine x sine x. All right. Then I also have sine x times cosine x to give me another cosine x sine x. And then finally, you have sine x times sine x that gives you a positive sine squared x. And this is going to be the result of multiplying everything together. All right. From here, we have additive inverses. That's right. Check this out. We have a negative cosine x sine x, and we also have a positive cosine x sine x. Yeah, those cancel out. Bye. And that means that these cancel out as well. That's fantastic. So once I have this, we'll then combine our remaining terms together. So what we have now is cosine squared x plus cosine squared x. That gives me 2 cosine squared x. Yep. Then combining sine squared x plus sine squared x, we have a positive 2 sine squared x. Just like that. From here, we're going to factor out a 2. Factoring out 2, that leaves me with cosine squared x plus sine squared x. And ladies and gentlemen, we should know that using our Pythagorean identity, that cosine squared x plus sine squared x is 1. So this all boils down to 2 times 1, which is 2. All right? Don't make a mistake on that last step. All right? And once again, I hate that check mark. I hate it. Better check mark. All right, we'll keep that one. We're going to keep this one. Okay, no, it's ugly. There we go. Perfect check mark. There we go. That's problem number 6. On to the next problem. In problem number 7, I have secant to the 4th power x minus 1 divided by tan squared x equals tan squared x plus 2. Well, what I have in the numerator is a difference of squares. I will be factoring that. So this becomes secant squared x plus 1 times secant squared x minus 1. All of this is over tan squared x. Okay? Using the Pythagorean identity, we can rewrite that tan squared x. So I'll be bringing down the numerator as is. All right, there we go. Bringing that all down. Yes, indeedy. All of this is going to be over. Tan squared x could be rewritten as secant squared x minus 1. All right? Same thing. So you should notice at this point that we have secant squared x minus 1 over one another. So we can just cancel those out. That leaves us with this secant squared x plus 1. However, secant squared x plus 1 can be rewritten using our Pythagorean identity into 1 plus tan squared x plus that existing plus 1. All right? So now we can just combine like terms, right? Because 1 plus 1 is 2. All right. Left side equals to the right side. There it is. For our last problem, we have cotangent x minus tan x divided by sine x times cosine x. This is supposed to equal to cosecant squared x minus secant squared x. Our first step, ladies and gentlemen, is going to be to separate these two fractions. Yeah, we're going to expand it. We're going to rewrite this as cotangent x over our denominator of sine x cosine x minus tan x divided by sine x times cosine x. All right? From here, we're going to rewrite everything in terms of sine and cosine. So therefore, that cotangent x using the quotient identity becomes cosine x divided by sine x all over this sine x cosine x. All right? Minus sine x divided by cosine x, that's me changing that tan x using that quotient identity into sine x divided by cosine x, which is all over sine x times cosine x. All right. From here, we're going to rewrite this to show that I have cosine x divided by sine x times 1 over that denominator, which was that sine x cosine x. All right. Minus sine x divided by cosine x times 1 over sine x times cosine x. All right, so this is what I have thus far. What we can do from here is we can simplify this, because here I can show that my cosine x's will cancel out, all right, in that first term, and then in the second term the sine x's will cancel out. So you're left with 1 over sine x times sine x gives you sine squared x, minus, then multiplying straight across, we have 1 times 1, which is 1, over cosine x times cosine x, which is cosine squared x. All right. From here, using our reciprocal identities, 1 over, or 1 divided by sine squared x is equivalent to cosecant squared x, minus 1 divided by cosine squared x is equivalent to secant squared x. All right. Our left side now equals to the right side. That's it. So once again, ladies and gentlemen, we have completed this series going over verifying trigonometric functions. That was part 4, and that's the end of the series. That's all 32 problems that I've personally handpicked to help you with this concept. All right, so hopefully it helped. As always, please rate, comment, and subscribe, and if you're able, please donate, as that helps us bring you more free math tutorials from Fort Bend Tutoring. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook, we'd be much obliged.